Hello. Today we'll do this problem, number 7 from the worksheet that we distributed last week. This is the problem that tells us that a rope pulls a 2 kilogram bucket straight up, accelerated from rest at 2.2 meter per second square for 3 seconds. And we have to calculate the displacement first, displacement of the bucket. We have to calculate the work done by each force acting on the bucket. So we have to first figure out that how many forces are acting on it. Then we have to calculate the total work done on the bucket in number C, and then calculate the net force on the bucket and the work done by the net force. And we have to compare our answer to the total mechanical work done on the bucket as calculated in C. That means we have to find out what is the net work done in part C and what is the net work done in part B, and we have to see that what is the difference between them, or are they same. Okay, so the first thing first is that we have to draw the free body diagram. So here it is. Look at these things. This is 2 kilogram bucket. And the rope pulls this one straight up, and acceleration is upward also, which means that the tension of the rope that the bucket is pulled is actually larger than the force of gravity, which is downward. So the force of the free body diagram will be like this. Okay, let me show you. Yeah, this is the free body diagram. So the mass mg is downward, and then the tension T is upward. And you can draw also the acceleration as a side note. The acceleration is also upward. Okay, so let us now do the problem, the part A. Okay, so what I will do actually, if I were you, I'll first write down what are the given. So my given are like say mass equal to 2.0 kilogram. See, it accelerates from rest. So my initial velocity v1, or sometimes we call it vi, whichever symbol you are using, the same thing, is rest. So 0 meter per second. Okay, and acceleration is 3.0. Sorry, it's not 3.0. Acceleration is 2.2 meter per second square, and time is 3.0 second. So in this question, we have to find out the displacement. We have to use this our knowledge of the 5 big equations from kinematics to find this figure that out. So let's see how we can do these things. Remember this equation: d equal to v1t plus half a times t square, right? So where v1 is the initial velocity, t is the time, and a is the acceleration, and t is the time again. And d is the displacement. So d is equal to, then what is v1? We will solve all the values. 0 meter per second times 3.0 second plus half 2.2 meter per second square times 2.2 sorry, what did I do? 3.0 square. Okay, so t squared is 3.0. Okay, so the first term will be 0 because it is something is multiplied by 0 is 0. So first term is 0, and then the second term is half times 2.2 meter per second square. Then this is second, 3.0 second square. So this will be then, if you square 3, it will be 9.0 second square. Okay. So what you have then, d is equal to then, if you multiplied all of them, you will get your answer. So let's, I'll keep them. I'll just use my calculator here to calculate this one. Where is my calculator? Let me bring it on. So this is half, so 0.5 times 2.2, and then times 9, which is equal to 9.9, right? So your distance is, let's go back to my PowerPoint again. Okay. So your answer is 9.9 meter. And 9.9 is in two significant digits. So I will keep 9.9 meter. So that's your first part A. In the second part, what we have to do, we will write down the given again. So now we also know the displacement. So let's see what we can find out. So calculate the work done by the H force. Okay, so there are two forces here. You can see that if you look at the free body diagram, right? One is a tension T, the other one is mg, right? So calculate the work done by each force acting on the bucket. We don't know each of these force, right? So how we can figure out this the two forces? mg is easy to find. mg is equal to fg, right? So we can figure that out. Fg is equal to what? Mass is equal to what is the mass? If you remember, 2 kilogram, you see that? So 2 kilogram. So Fg mass is equal to 2.0 kg, and G is equal to 9.81 meter per second square. Fair enough. So Fg will be then, again, I will be using my calculator. I'll keep everything. My calculator is, so not 9.9. So I'll be doing mg 2.0 times 9.81, which is 19.62, which is, let's go back, which is 19.62 Newton, right? And T is upward, we don't know, but we know the acceleration. Acceleration is equal to A equal to 2.2 meter per second square. Okay, so now since we know the Fg and we know also, we find out the displacement D, which is 9.9 meter. So we can figure out what will be the work done by the force of gravity. Now, one thing you have to notice, we'll do it a little later, but one thing you have to notice is that where is the displacement looks like. Since you are moving upward, the displacement will be upward also. So I'm drawing it now. So this will be your displacement. So this should be straight upward. Sorry for my wiggly line, but this is upward straight line. Okay. So this is my D. Okay. And now you can see that T, that force of tension, and the displacement, they are in the same direction. So the angle between T and D, angle between force tension T and D remember what should be? They are in the same direction. Angle between T and D is 0, right? So theta equal to 0 degree because they are in the same direction. And angle between FG and D is exactly opposite. D is upward and FG is downward. So theta should be equal to 180 degree. Now, knowing that, if we can find out what is the value of T, we can actually calculate the work done by the tension, force of tension, and by the FG. FG is readily we can do these things because we know FG and we know D, we know the angle. It is easy. We can do it, but let's figure out what is the tension T. To find that, we have to figure out what is my net force. We know that my net force is, from the picture, from the free body diagram, is tension T minus Fg. Tension T minus Fg. T is upward, Fg is downward. That's why they are like this. From the picture, it is clear. T is upward, Fg is downward, okay? And also, F net equal to, from the Newton's second law, mass times acceleration. We know the mass is equal to 2 kilogram and A is equal to 2.2 meter per second square. Acceleration is also given, it is upward, right? And it's positive. So combining these two, we can write that T minus Fg is equal to ma, right? Then we can arrange these things like this, that I can isolate T, Fg is on the other side. So T is equal to ma plus Fg. Now I'll sub all the values. Look at here. T, m is equal to 2.0 kg. A is equal to 2.2 meter per second square. And Fg we just calculated, which is plus 19.62 Newton. Okay. So this is your tension T, right? And the first part is your MA, which is the net force. So if you multiply, this will be T is equal to 4.4 Newton plus 19.62 Newton. If you add this together, so T is equal to 4.4 plus 19.6, what you get? Let me check. I will write down, I'll use my calculator. 4.4 plus 19.62, which is equal to 24.02. Okay. So 24.02 Newton. 24.02 Newton. Okay. So this is the force of tension. You also know force of gravity. We know the angle. So let's call it work done by the tension force, which is equal to T, T, then times D, and the cosine angle of 0 degree. So T is equal to 24.02 Newton multiplied by the distance is displacement is 9.9 meter. Cosine 0 is equal to 1. So if you calculate that, so 24.02 times 9.9 times 1. Let me grab my calculator and then we can do it. Okay. Okay, I have my calculator. I'm calculating it now. You can do it also. So, which is 24.02 times 9.9, which is equal to 237 point 237 point 238 joules. I can rearrange 238 joules, or you can, in two significant figure, you can say that it is 240 joules, okay? And work done by the force of gravity, WFG is equal to, you can say FG times D times cosine 180 degree. Again, why it is 180 degree? Because FG is downward and D is upward. They are in the opposite direction. And FG is equal to 19.62 Newton. D is equal to, again, the same 9.9 meter. And cosine 180 degree is equal to -1. Please check that. And this give me negative 19.62 times 9.9, 194.238. So 194.238 joules. So for the sake of two significant figure, we can say that this is 190 joules. Okay, so this is part two. So the part two, this is work done by the tension, force of tension is 240 joules, and work done by the force of gravity is, sorry, this is negative because of this negative sign, it -1, it will be negative. So negative 190 joules. So these are two work done by the tension 240 joules, work done by the force of gravity is negative 190 joules. All right. Part C, you have to find out the total mechanical work done. That's very simple. Total work done will be W total is equal to work done by the tension plus work done by the FG. Okay, let's just look at 238 joules and 194.238. Or you can use 240 joules here. 238 point, let me, 38 joules and negative 194 joules and negative 194 joules. And then if you subtract these two, you will get the total work done, 238 minus 194, which is equal to 56. Sorry, again, 238 minus 194. So sorry, 44 joules, positive 44 joules. Okay, so that's part C. Simple, you just add them together. Now in part D, it says that calculate the net force. We did actually, but we did not show it. So F net is equal to mass times acceleration. Mass is equal to 2.0 kilogram, and acceleration is 2.2 meter per second square, which is equal to 4.4 Newton. This is your net force. So total work done, or the work done net, whatever way you call it, net work done or the total work done, is equal to F net. F net is equal to upward because the T is bigger. So F net is always in the same direction as the acceleration or the bigger force. F net times D times cosine 0 degrees. Since the net force and the displacement in the same direction, so the angle should be 0 degree. So F net is equal to 44 Newton. D is equal to 9.9 meter. Cosine 0 is equal to 1. Let's check it out. What is that? So you multiplied 44 with 9.9, 435.6, 435.6, joules. Okay. So, oh, okay. Sorry, it's my bad. You can see that it's a 4.4 Newton. So I use 44 Newton. Okay. So actually 4.4. So I will get this one like this. 4.3. Sorry, it will be 4.4 multiply 4.4 times 9.9, which is equal to 9.9, which is 43.56, 43.56 joules, and equal to actually 44 joules in two significant figure. And if you compare C, part C, and part D, you can say that total work done in part C was 44 joules, and in part D, W net is 44 joules. They are same. Okay. So whichever way you calculate the work done, so there are two ways to calculate the work done. If there are multiple forces acting on the object, in this case, tension and Fg. So you can figure out the net force, and from the net force should be always in the same direction as the larger force. So from that, you know that the displacement is in the same direction as the larger force. So from the angle between net force and the displacement is 0. So from that, you can figure out what should be your the angle cosine 0 is 1. So from that, you can you figure out that F net times D times cosine 0, that is 0. Yeah, sorry, I did not put the decimal here. Now it is right. So it is 43.56 in this case. And in part C, if you go back, we can clearly see that if you add these two, it is 44 joules. So they are same. All right. So that's all for these questions. I will upload this one, and then you can also look for the problem number 8, which I will do it shortly. Okay. All right.